So, this is already the episode 4 of the present value series, and today I'm going to talk about the present value of one annuity due or annuity in advance factor. So, the same with the flow in the previous episodes, we are going to talk about the concept and the formula first, but now we are going to talk about the present value of one annuity due or annuity in advance factor. And then, we are also going to talk about a sample illustrative problem and we are going to solve it to apply what we will be learning later. And lastly, we're going to talk about also how to compute the annuity due factor using both the scientific and the basic calculators. But before we start this, please see the previous 3 episodes. Their links are on the description below. And if you already did that, then let's get started. So, what is this present value of one annuity due or annuity in advance? So, it is a factor or a number used to get the current value of your receivable or payable, which are settled in multiple uniform payments, just like the ordinary annuity factor. But the twist with this one is that the multiple uniform payments in the annuity due or the annuity in advance are paid at the beginning of each of the periods. So I'm going to highlight beginning of each of the periods. So don't be confused, okay? So let's compare it with the ordinary annuity factor. The ordinary annuity factor in the past episodes, the payments there are made at the end of each of the period. So you need to remember that. Okay? So let's go to the illustration. So the illustration states that as if you are to pay 300,000 at the beginning of each of the 3 years. I repeat, the beginning of each of the 3 years. So the question is, what is the current value or present value of your debt today? If the effective or the market interest rate is 12% per annum. So here's the pattern of payments based on the illustrative problem. So if this is now, the first payment is made immediately in this date. And then, the second payment is made at the end of year 1. But I need to make it clear that this end of year 1 can also be treated as the beginning of year 2. That's why I made this label, so that it will fit with what I told you earlier that annuity due or annuity in advance factor is applicable for payments that are made at the beginning of each period. Okay? So, let's go back here. The third or the last payment is here at the beginning of year 3, or you can say at the end of year 2. That's basically the same. But please notice here, there are no payments already at the end of year 3. So, this is the pattern of payments where the annuity due factor can be used. But before we complete this timeline, let me make something clear, okay? So, I know that something is a bit off. Like for example, if this is now, then this is as if the exact time you availed for a loan, right? So, it's very illogical that at the date of getting the loan or the loan proceeds, you are to pay immediately the first payment of 300,000, right? So, to make this a little bit realistic, let's assume that you availed a loan of 3 million and that these 3 payments of 300,000 here are the payments of interest. And let's ignore the principal of 3 million for this video and let's focus on the interest payments, okay? So, now it will be more realistic. Why? Because advance payment of interest is really happening in real life. Like, if we follow our made-up illustration, if you availed a loan of 3 million, there are times in real life that the proceeds that you will receive is not already 3 million. It has already been deducted with interest. And if we follow that, as if, you will only receive from the bank 2.7 million. Because from 3 million, this 300,000 as if has been taken out and is paid in advance. I hope you still follow. So now, Let's fill this timeline up. So please forget about the 3 million earlier before we fill this timeline. I only gave you that example so that we can justify the pattern of paying immediately even when the loan was only just released. Okay? So again, please forget about that 3 million sample. And let's focus on this illustrative problem. So again, we are trying to find the amount here. And again, even if we don't know this yet, we know that every year this amount will grow by 112%. 100% for the principal and 12% for the interest. So these question mark amounts minus this first 300,000, the unknown difference will be multiplied by 1.12. And then we will get something here. And minus the second 300,000 and we will get something here. And for the last time, this supposed to be amount here times 1.12 equals this one here. And minus the last 300,000, so 0. And now, let's work back. It's just the same with what we did in the previous episodes, okay? So, this one here is 300,000, right? Divided by 1.12 because again, we are working back. And we will get 267,857. And then, plus 300,000, then this should be 567,857 divided by 1.12, and we will have 507,015. And then we add 300,000 back, and then we will know that this question mark must be 807,015. And that's what we are looking for. So we did not yet use the present value of annuity due factor, but we still got the answer, right? Why? Because there are a lot of ways to kill a cat. And again, what we did here is the timeline analysis solving. Okay? But this type of solving will be illogical if we're talking about 20 years, 30 years, or longer periods of maturity periods. Okay? That's why we still need to study how to get the present value of one annuity due or annuity in advance factor. So, before we continue, let's compare this payment pattern with the pattern in the ordinary annuity in the previous episode. Okay? So, in here, the payment started immediately. And in the final year or at the end of year 3, as you noticed, there is no payment already. While here, in the ordinary annuity in the past episode, from now, we waited 1 year first before we paid the first 300,000. And of course, the last payment occurred at the end of year 3. So again, ordinary annuity is good for multiple payments made at the ending of each period, while annuity due or annuity in advance factor is used to solve for the present value of debt or receivables settled using multiple payments made at the beginning of each period. Please remember that. Okay? So, let's move forward. Actually, guys, you can also use the simple present value of 1 or the simple 1 plus I raised to the power of negative n to get this amount. How? Again, you just need to treat each of these 300,000 payments as separate debts. So, let's start. So again, the present value of one alternative is done by multiplying the future payments times 1 plus I raised to the power of negative n. So you still remember that, right? So the first payment of 300,000, which is this one, times the 1.12 raised to the power of 0 or negative 0. 0 because they are paid immediately now. And if you try to calculate this formula, I'm sure the result will be 1. So 300,000 times 1 is 300,000. On the second payment, we have 300,000 times 1.12 raised to the power of negative 1. And the result for this formula will be 0.89286 rounded off to the nearest 5 decimal places. And we multiply it with 300,000, then you are gonna get 267,857. And the last payment is multiplied to 1.12 raised to the power of negative 2 or 0.79719 as the factor. Again, 300,000 times 0.79719 and we will get 239,157. Okay? So let's sum all of this and you will get 807,015, which is the same with this one. So now, it's time to use the present value of 1 annuity due factor to get the present value of debt or receivable. Again, we use this factor so that we will not have any problems even if we're talking about a long maturity years, like 50 years, 30 years, or 40 years, okay? So, the solving or the pattern is still the same, which is payments times the factor. However, the formula to get the factor is a little bit longer now. But there is a technique to remember that. Like, we can just review all the factors that we have talked about starting from the present value of 1. And from there, let's add something bit by bit, okay? So let's start with the 1 plus I raised to the power of negative n. So that's present value of 1. And then, let's add this 1 minus here and the over I. And we will now get the present value ordinary annuity factor formula. And then in order to get the annuity due factor or the annuity in advance factor, we need to add 1 in this negative n. And after getting this numerator and denominator, if after you have summarized this, we need to add another 1. So that's already the formula in getting the annuity due or the annuity in advance factor. So again, let's repeat those but in bigger fonts already, okay? So 1 plus I raised to the power of negative n is for the present value of 1, right? And then add this 1 minus here and this over I, then we will have the present value of 1 ordinary annuity factors formula. And then add 1 in the negative n here and this plus 1 and you will get the formula for getting the annuity in advance or annuity due factor already. Okay? So that's how you remember the complicated formulas for getting the factors. Okay? Now, let's apply this in the illustrative problem. And we will have 300,000 times 1 minus 1.12 raised to the power of negative 3 supposedly. But because of this plus 1 here, so we are going to use already the negative 2. So divided by 0.12. So after summarizing this fraction, the numerator over the denominator, then let's add 1. And we are supposed to get a factor of 2.69005, rounded off to the nearest 5 decimal places. Okay? So 300,000 times 2.69005 equals 807,015. So this is the same with this one and this one. And that's it for this episode. So in the next episode, we will use the basic and the scientific calculators to get this factor. And thank you for watching the episode and see you on the next one.